How do we interpret wavelength? Wavelength is related to what we perceive as the color of the light. As you know, visible radiation ranges from 400 to 800 nanometers. And the term electromagnetic spectrum refers to the range of possible wavelengths. And so it goes from very short frequency to very high frequency. So the type of electromagnetic radiation that your eyes are sensitive to, the ones that your eyes can detect, can perceive as color, only refers to those with wavelengths ranging from 400 to 800 nanometers. So near the red end of your electromagnetic radiation, you have the 800 nanometers around here, and near the violet end, you have 400 nanometers. Okay, so past the red, you have longer wavelengths. Those types of electromagnetic waves are called infrared, and even longer wavelengths you have microwaves, okay, and then longer than that you have radio waves. So what type of electromagnetic radiation is 102.5 megahertz? That's your FM radio station, right? So that's a radio wave. And the radiation in your microwave oven will be longer than this, so it's past the red end of your electromagnetic spectrum. So the terms red and blue are usually used as adjectives when referring to things related to waves and light. You say there's a red shift, that means shifting towards longer wavelengths. A blue shift would be shifting towards shorter wavelengths. Okay, shorter than violet would be ultraviolet, and then even shorter than that would be X-rays. So, so that's going to longer wavelength, and that's a longer wavelength means lower frequency. Why is that? C is lambda times nu, right? So if nu can be written as what? C over lambda. So you can say that nu and lambda are inversely proportional. So the longer your wavelength, that means the lower the frequency. So radio waves would be what you would call low frequency radiation. All right, let's see. What type of color corresponds to longer wavelength, red or blue? Red. What type of radiation corresponds to longer wavelength, microwave or X-rays? Microwave.